Hey everyone, welcome back to Age and Education channel. We shall continue today with the topic refraction. And as a part of this, we shall look into the concepts of critical angle, and then comes the concept of total internal reflection. See, remember here, don't think that it is refraction. Okay, this is reflection itself, total internal reflection. Why is it called so? I'll let you know. Okay, so the first concept we will be covering is critical angle, and the second concept is total internal reflection. The third concept, if the time permits, we will get to see about dispersion too. Okay, so first we shall look into critical angle. Okay, first let me tell you what are the essentials for the concept of critical angle. Okay, for this the light should travel from denser medium to less denser medium. Okay, why do we have to say this? It is because when the light goes from denser medium to less denser medium, what happens? As I have mentioned, right, when it does like that, then will it move away from the normal or towards the normal? If it moves from denser to less denser medium, it will move away to the normal, right? So it should, usual path should be this, but it tend to move away, so it will go somewhere like this. Okay, now here, in order to understand this concept of critical angle, what we do is that we want an angle of incidence. Okay, so this is related to angle of incidence. Okay, remember that this is not about the angle of refraction. We are talking about the angle of incidence, which makes the refracted ray to make 90 degrees with the normal. Okay, so don't get worried with all these words. I will let you know. Okay, when I draw something, you can easily understand. Okay, consider this to be this surface. Okay, so this is denser and this is less denser medium. Okay, from high denser medium to less denser medium, right? So when this is making, when an incident ray has fallen upon this, and this have to pass to the less denser medium, right? Now you will draw a normal as such. Okay, now this angle, we are talking about this angle. Okay, this angle will be called a critical angle if the refracted ray, it means the ray that is bending, okay, that ray, if it makes 90 degrees with the normal, it means that the ray will come like this and it should go like this. Okay, if this happens, if the refracted ray is able to make 90 degrees to the with the normal, then the angle at which the incident ray has fallen upon this is called as critical angle. Okay, you want me to explain again, I think, right? So I'll do that in the next page. I'll give a bigger picture. Okay, so assume this is the line of separation between the two mediums. Okay, so this is the which medium? Yes, higher density medium, and this is lower density medium, right? So when an incident ray, incident light ray, okay, when it falls here, what you do? You draw a normal, right? And when the refraction has to happen, like it means that when this light ray has to bend while moving into the lower density medium, as the light ray is moving from higher density to lower density, it will move obviously away from the normal, right? So usually it should go like this, but instead of this, it will go away. So it has to be somewhere here in this area, right? Now the concept of critical angle comes in, where you say that if this angle of incidence is critical angle, then the refracted ray, okay, the refracted ray will make an angle of 90 degrees with the normal. So the refracted ray should go this way, such that it will make 90 degrees with the normal. Okay, then this angle of incidence can be called as critical angle. Okay, so an angle of incidence can be called a critical angle if the refracted ray makes 90 degrees with the normal. Okay, so here this is the concept of critical angle, and with this critical angle concept you can further delve into the concept of total internal reflection. What is it? Not refraction, don't get confused. Okay, total internal reflection. And it is very important to understand this concept, as there are so many applications. I will let you know later. Okay, now we shall continue with this concept itself. Now you said that with this critical angle the refracted ray is making 90 degrees. Okay, now if you further increase this angle, when you further increase this angle of incidence, it means that if the angle of incidence is more than the critical angle, then it is obvious that the refracted ray will get back into the denser medium itself, because this angle will also increase, right? So if this angle increases, this angle will also increase. So what is happening here? The ray is getting reflected instead of refracted. Okay, refracted means it is moving into some other medium, and because of the change in the densities it has to bend. But now here it is not getting refracted, it is getting reflected. It means it is reflecting back into the same medium because of the angle, right? It is all about the concept of angles here. As your incidence angle of incidence is more than the critical angle, then because of that this angle, the angle of refracted ray, has also increased and it went beyond 90 degrees. And if it is beyond 90 degrees, then it means that the ray, instead of getting refracted, will get reflected. Right? Everything is clear, right? So the word reflection has come here, right? So what are the key conditions of total internal reflection? We have understood the concept of total internal reflection. And what are the conditions? The key conditions would be that the light must travel from denser to rarer. Rarer means less denser medium. Okay, so this is the other name to less denser medium as compared to this. This is higher density medium and this is the lesser density medium. Okay, so always the light should travel from less high denser medium to less denser medium. Okay, the other condition, the key condition would be that the angle of incidence should be more than critical angle. Okay, in this scenario what happens is that the angle will get, the ray will get reflected back into the same medium. Okay, with these conditions the light ray will get reflected back into the same medium instead of getting refracted. Okay, so as I have mentioned earlier, it is a very important concept and you can find this concept in many scenarios. Okay, let us see each of them. Okay, so what are the applications of total internal reflection? The first application is optical fibers. Okay, and mirages. Next would be in binoculars. Okay, and apart from this, the natural phenomena like rainbow, the diamonds having that charm and brilliance, all this is also because of the total internal reflection. Okay, so here what happens is that optical fibers, here in the optical fibers the light will just move like this, like this, like this, like this, and the signals will get amplified. Okay, so here light signals are confined within the core of the optical fibers because of the total internal reflection, and this enables efficient data transmission. What is it? Efficient data transmission. Okay, and this is a very important concept. Only because of this all the technology and everything has increased tremendously. Okay, because the data has to be transmitted, and it is very important that it be efficient. Okay, so this concept of optical fibers has revolutionized everything. Okay, and this is possible because of the total internal reflection. And mirages, okay, it can be observed where? Do you remember? Yes, deserts. It's like an illusion, right? Illusion that there is some water. In desert, what happens is that see at a place, see from a place, okay, you will find that at some distant place you will see there will be some water or something. Okay, but when you really go there, you won't find anything. So illusion of presence of water. Okay, illusion of presence of water. This is also because of the total internal reflection. Okay, next is in binoculars. Binoculars also this concept of total internal reflection will be there, and in rainbow and diamonds, everywhere or in all these you can find the application of total internal reflection. These are natural things that we won't do anything here, and these are man-made things. Sorry, not this is not man-made. This is also natural. Optical fibers and binoculars. Human has used this concept of total internal reflection to enable us to increase the technology. Okay, so mirages, rainbow and diamonds, these are the natural applications of TIR. Okay, why I am saying is that in your why I am specifying this differences as natural and man-made, you may get a question stating that find the odd one out. Okay, and they may mention as mirages, rainbow, diamonds, binoculars. So what will be the odd one out here? Binoculars. It is because the applications of total internal reflections are natural here, and here it is man-made. Okay, so you can expect these sort of things too. And for your 7th grade you need not get into the greater detail as how all the everything works. Okay, you need not get into modus operandi. What is important is what are the applications of total internal reflection. You should keep that in your mind. Okay, next we shall look into dispersion of light, right? So about dispersion of light, what is this? Dispersion occurs when white light, okay, when white light splits into its constituent colors. Okay, splits into its constituent colors, or you can say that spectrum of colors. Okay, spectrum of colors, and this spectrum will have 7 colors in it. Okay, that is the very reason the rainbow also has 7 colors. Okay, but when will this split happens? How will it happen? It will happen when this white light passes through a prism. Okay, when the white light passes through any prism, then what happens is that because of the concept of refraction, the white light splits into its constituent colors. Okay, when there is any ray like this, then here there will be refraction. You can see the concept of refraction here because there is a change in the medium, and again when it reaches this end, then again there will be change in the medium, and so there will be further refraction, and overall when you are sending a white light, and what you can see is spectrum. Okay, it has 7 colors. Okay, because of this very concept, you can even see the rainbow. Okay, we will see a bit in detail about the rainbow too, because we have even mentioned that rainbow also has the concept of total internal reflection, right? We will see how actually the rainbow you will be able to see different colors of the rainbow. Okay, I don't think you have you will have anything with regard to academics about all these details of rainbow, but I want you to understand how the rainbow is formed, so that this dispersion of the light concept and total internal reflection of the light, everything will be clear to you. Okay, and as far as academics is concerned, I don't think you will need to learn about this concept of rainbow in this much detail. Okay, you just have to know the names and what happens in the with regard to the rainbow. That's more than enough. Okay, now okay, white light splits into its constituent colors when it passes. Okay, now let us get into this concept of rainbow. Okay, all right, I forgot to mention, why is this happening? Why actually the white light is getting split up into 7 colors? This is because the wavelengths of the different colors differ. Okay, wavelengths of colors differ, and because of this the capacity to refract also differs. Like shorter wavelengths like violet, okay, violet have the capacity to refract more, will refract more as compared to longer wavelengths like red. Okay, so because of this difference in the capacity of refraction, you can find that, you can see that when these has passed through a prism, there is difference in the density, and because of this refraction occurs, and when this refraction is occurring, because of the differences in the wavelengths, some will refract more and some will refract less, and so you will be able to clearly see all the colors in a separate manner. Okay, so shorter wavelength like violet will refract more as compared to the longer wavelengths like red. Okay, you know this VIBGYOR, right? VIBGYOR, all the colors violet, indigo, blue, green, yellow, orange, red, and here you have the shorter wavelength, and here you will have the longer wavelength. Okay, so the capacity to refract is more here as compared to red. Okay, and this keeps on decreasing, and it will be least here. Okay, because of this differences in the wavelengths and the refracting capacity, you will get to see a spectrum when the white light passes through the prism. Okay, I hope now everything is clear with this. We will get into the concept of rainbow. Okay, how about the other applications? Okay, we will look into the rainbow too. You can say that dispersion of the light will occur. Okay, the first thing is rainbow, and there is a concept called as spectroscopy. Okay, even here it is used. Okay, and you can see this concept, this dispersion of the light, even in Newton's disk. Okay, this concept, the very important thing I forgot to mention is that it was first discovered by Sir Isaac Newton. Okay, he discovered this concept of dispersion of light. This is an important question. Okay, I thought I will let you know about this at the end, so that you can easily remember after the concept gets clear. Then you can imagine as how great this concept is and who has actually discovered this concept. Who did this? Sir Isaac Newton has done this. Okay, now about rainbow. Okay, I have just realized that the time is almost 19 minutes and I don't want to overburden you in the single video. Okay, I will discuss about this concept of rainbow in the next video. Okay, before that you just once again go through the video. It is because many important concepts are covered here. It is better to understand everything, so that the other topics, the upcoming topics, would be easy for you. Okay, thank you, bye.